Good afternoon and welcome to the latest in our PV Tech series of webinars. Today's is hosted alongside module manufacturer JA Solar, exploring the technology and application of bifacial PV modules. My name's Liam Stoker. I'm the UK editor at PV Tech publisher Solar Media, and I'll be your host this afternoon. Today's presenters will be JA Solar's Henning Schulze and Morgane FLEURANCE. Both Henning and Morgane will give a presentation on today's subject, within which we will have some interactive polls. I'm aiming to finish with a short question and answer session. But without further ado, I'll hand you over to both Morgane and Henning.
Yeah, thank you, Liam, and good day to everybody and welcome to today's webinar. My name is Henning Schulze, and at JA Solar, I'm in charge of the company's European business and also of business with European customers outside of Europe. Now, before we will dive right into today's main topic, please let me give you a short introduction to JA Solar. The company was founded in May 2005 and went public on the Nasdaq in February 2007, and we are headquartered in Beijing. Last year in 2017, we had a total shipment of about 7.6 gigawatt peak, and we were the number 3 globally in terms of module shipments and even the number 1 in terms of in-house cell production. At the end of March 2018, we had about 15,000 employees, and what we strive at is to obviously stay an industry leader. We've been able to convince the markets and also the financiers through our very stable financial situation over the years. We strive towards manufacturing excellence and always want to keep an edge on the product side through being very innovative in our products, and we aim at a very broad global market coverage and a diversified customer base. When it comes to our products, we aim for high conversion efficiency, high reliability, and high yield efficiency when our modules are out there in the field generating electricity. Now, JA is quite vertically integrated, so we produce some in-house wafers, cells, and modules. Our current wafer capacity is 5 gigawatt peak, our cell capacity is 7 gigawatt peak, and our module capacity currently is 8.5 gigawatt peak. And when it comes to our products, we've always been offering a very broad product range to the market. So this obviously is 60 and 72 cell modules, 1000 volt and 1500 volt versions of our modules. In addition to the traditional glass backsheet design, we also offer double glass monofacial, and now, and obviously today's presentation is mainly or is on this product, bifacial modules. Plus, in addition to modules using the standard junction boxes, we also offer modules using smart junction boxes, so junction boxes with embedded optimizers. For specific aesthetic demand, we offer full black versions of mainly our mono modules, and as a manufacturer, we offer in mass volumes both major technologies out in the market, which is standard poly and also mono PERC. So both of these technologies we offer in mass volumes. When it comes to our production lines, we've also always been striving to using really state-of-the-art equipment in order to ever increase our productivity, in order to be able to provide, to supply to the market the newest technologies and products. One very recent example is that in one workshop, which has an annual production capacity of 1.5 gigawatt peak, we have recently introduced self-learning robots. So self-learning equipment has now also made its way into the JA production lines. And again, the aim is to always stay at the head of the pack and use top state-of-the-art equipment in our factories. Further, we boast of very strict quality control internally and also in cooperation with third parties. Our modules are tested to withstand 3 times the IEC test criteria. Further, we have a very strong focus on R&D. JA started as a pure cell manufacturer, and we've always been leading in R&D cell activities. And our laboratories are also state-of-the-art. They have been qualified as official testing facilities by TÜV South and also Intertek. Now, after this short introduction to JA, please let me give you a brief introduction to the background of today's webinar. Obviously, the question we have been and we constantly ask ourselves is, what will be the technology trends in the coming years? Now, looking back a bit, for a long time, the 2 most common technologies in the industry were P-type polycrystalline and P-type monocrystalline technology. Obviously, polycrystalline in the past with a bigger market share than monocrystalline. Now, in the last few years, couple of years, P-type monocrystalline PERC technology has won market share. JA was also one of the companies to really be the first to drive this technology into production, into the market. But we see it also just as one further step in the whole evolution of PV module technology. And of course, we ask ourselves, what will be the future technology, or maybe the future technologies? Will it be N-type? Will it still be some type of P-type? Will it be IBC? Will it be bifacial? Or will it be thin film maybe even? Now, when we ask ourselves this question, our objective, of course, is what can we do at JA to help the industry through our products drive down the levelized cost of electricity? So what we can do in order to make us, the whole PV industry, more competitive compared to other technologies that generate electricity. And we believe that bifacial, mono, PERC cells, and these obviously made into modules, have a very great potential. And Morgane, she will later lead you through the presentation, but before she starts, I will give the word back to Liam, who will present 2 polls to you.
Yes, thank you, Henning. We do, like I said at the introduction, we do have a few quick polls for you. If we could just bring them up on the screen now. So the first poll on the screen you can see now. Do you have a plan to use bifacial modules in your designs in the next 12 months? We have 5 questions there. If the participants in today's webinar could give some answers. So there we see on the screen from the attendees today, the kind of significant majority there, 44% say that we are interested, but we are waiting for more information on bifacial technology. 28% say that we have already used bifacial or planning to deploy bifacial modules. 16% say that there is no plan yet. They are still yet to be convinced of the benefits of bifacial modules. And then 3% say they are unconvinced, with a further 9% they're saying that they are unsure. And then we have the second poll that we'll go through now. Which module technology do you foresee produces the lowest LCOE on your projects? So there's standard poly modules, mono PERC modules, bifacial mono PERC modules, non-P-type module technology such as thin film, or if you're not sure, there's a separate answer there as well. So a fairly conclusive answer there. 34% say that bifacial mono PERC modules will produce the lowest LCOE on certain projects, with standard poly modules as the next best option. Mono PERC modules secured 17% of the vote. However, quite a few, just over a fifth there, 21% weren't sure. So those are the 2 opening polls that we have for today's webinar. But now I can hand you back to Morgane FLEURANCE, who will continue with the presentation.
Thank you. Good afternoon, everyone. So I'm Morgane FLEURANCE, Product Manager at JA Solar. Thank you for attending this webinar today about bifacial modules. Let me present you first the outline of today's presentation. In the first part, we will define the technology, going through the mono-PERC baseline products, then the bifacial cell technology and bifacial PV module technology and advantages. In a second part, we will focus on bifacial module gain, and in the last part, we will study some applications with field data and simulated data. So it is important to present first the PERC technology. It is nowadays the leading mono technology. PERC stands for passivated emitter rare contacts, but what does that mean in practice? Compared to a standard solar cell, an extra layer is applied at the backside of the cell. This is what is called on the right diagram, the passivation layer. This layer acts as a mirror. So in a standard cell, the light is absorbed by the cell, and when reaching the cell rear side, the light is dissipated. In a mono-PERC solar cell, the light is absorbed, and when reaching the rear side of the cell, so this passivation layer, it will be reflected by this layer, and we will have a second light absorption. It helps to increase the solar cell efficiency, the current, the voltage, and we can have more energy per square meter. Right now, the main power class for 60 cell mono-PERC modules is 305 watt peak. This technology has mainly two advantages. First, it has a superior low light performance compared to conventional modules. It means that in cloudy, rainy weather, the mono-PERC module will perform better compared to standard modules. The second advantage is lower temperature coefficient, so better performance in high temperatures as well. These advantages lead to a direct gain in the field. This is what we have shown for what we have seen on projects. The China Frontrunner project, where 50 megawatts peak were installed using standard polycrystalline and mono-PERC modules. We have monitored energy generation for more than 1.5 years. And we have seen that mono-PERC modules generate 3% additional energy yield compared to polycrystalline modules. Since the front side power of the module is higher compared to polycrystalline modules, it can also help to have 7% land saving. Now let's move on to the bifacial PV cell technology. So we need to compare now the monofacial PERC solar cell and the bifacial PERC solar cell. The difference is that a mono-PERC solar cell is taken and a grid is printed at the backside of the cell. This is in order to collect light from the cell rear side. Bifacial N-type and P-type cell can coexist on the market. The main difference is on the efficiency on the front and rear side. JA Solar has chosen to develop P-type bifacial solar cell. Regarding the bifacial PV module technology, so the bifacial cell are encapsulated into a double glass module design. So a glass is placed at the rear side of the module, and the encapsulant used is POE material. The module can be framed using silver or black version frame or frameless design. It has an extended warranty for 30 years and 0.5 annual power degradation. For bifacial PV module, we need to define the bifaciality factor, which is the power of the rear side to the power of the front side at STC. For P-type module, it is usually between 70 to 75%. So here On the picture on the right side, you can see that in this example, the bifaciality factor is 70%. The rear side power is 210 and the front side power is 300. Thanks to the module rear side generation, the bifacial module can leads to a higher yield and electricity production, and it helps to decrease the levelized cost of electricity. Now, let's detail the bifacial PV module advantages. As you can see from the picture on the right, for the module front side, it can catch direct radiation from the sun. Regarding the module rear side, it can catch either diffuse radiation or reflective radiation. This leads to a direct energy gain, an increase of 3 to 15%, depending on many parameters that we will detail after in the presentation, as the reflectivity of the ground, the installation tilt, the height, etc. Similar to the mono-PERC module, the bifacial module has an excellent temperature coefficient and superior low light performance, also due to the fact that more diffuse light can be absorbed through the rear side of the module. Thanks to the double glass module design, this module is highly reliable in harsh environments. Let's move on to the second part, which is the bifacial module gain. First, we will define what is the bifacial gain, and we will go through different factors influencing the gain. The definition of the gain of a bifacial module. The gain is the energy produced by a bifacial module minus the energy of a monofacial module to the energy of the monofacial module. This gain is expressed in percentage. We wanted to quote this sentence from IC Constant Institute. Comparing apples with apples for bifacial modules sometimes does not make sense. Why? Because you have many varying parameters. First, the baseline product technology. Are we talking about N-type, P-type, poly or mono-PERC modules? In the next simulation, we took as a baseline product technology the mono-PERC modules. Another varying parameters is the module design or the bifaciality factor. You also have to consider the installation parameters, the installation tilt. For instance, comparing a bifacial module installed vertically with monofacial modules installed vertically does not really make sense because the gain would be higher than 100%. You also have to consider if the installation is with or without tracking, how is the spacing between rows, the location of the module in the string in the layout, and the environmental conditions, the irradiance, and finally, a very important factor, which is the ground surface reflectivity, also called albedo. The first factor influencing the gain we will study here is the module design directly related to the bifaciality factor. We could think that the highest the bifaciality factor is, the highest the gain would be, but we will see that this is not necessarily true. The design one, we have studied several bifacial module design. The design one is using a fully transparent rear glass, so meaning that in the gap between the cell you can see through the module. The rear glass is transparent. In this case, the bifaciality factor is usually higher than 70%. The design 2 is a partially transparent rear glass. This is what we call ceramic glass. So In the gap between the cell on the rare glass is placed a reflective layer, a white coating. And thanks to this layer, as you can see from the diagram, the lights will be reflected on this layer back to the front side of the glass and back again to the front side of the solar cell. It helps to increase the front side power of the module. Since the bifaciality factor is defined as the power of the rear side to the front side, if the front side power is increased, then the bifaciality factor will be slightly lower. Here it's around 70%. So as you can see from the picture, if you look at the module from the front side, the module looks like a regular glass backsheet module. We have tested and we have installed these two design modules on a field, and here is the result that we found. We placed the design 1 module, the design 2 module, and a regular monofacial module installed all in the same configuration, and we monitor the energy generation. The energy gain of the design 1 module was 7.5%. The energy gain of the design 2 module was 11%. We have shown here that bifacial module using partially transparent rear glass has higher energy yield compared to the design 1 module. JA Solar has chosen to develop as a standard the white design module. It is more important to prioritize the module frontside power rather than the backside. So in fact, here we have proven that the bifaciality factor is a wrong indicator for the bifacial module performance. The second factor we are studying here is mounting methods, and here more specifically about the height. We have installed a regular PERC module at different heights, and the design 2 module at heights of 1.5 meter and 2 meter. We monitored the energy generation, and we saw that raising the installation height by 0.5 meter increased again by around 1%. So the height plays a fundamental role here. When placing the module higher, the rear side can actually catch more reflected and diffuse lights. This leads to the recommended mounting methods. So we would recommend to install the bifacial module with a tilt angle of at least 30 degrees. The length that you can see on the diagram of the installation array should be less than 2.5 meter in order to avoid shading also on the module rear side. The distance between rows should be long enough, and installation heights should be at least 0.5 meter. The next factor influencing the gain we will study is the climate conditions. Here the graphs plot the gain of bifacial module versus monofacial modules. The blue line shows the gain of the design 1 module, and the red line shows the gain of the design 2 module. Two conditions have been studied, a sunny day condition and a cloudy day condition. First of all, what we can see is that the gain is always positive any time of the day. On the morning and evening time, what we can see is that the gain is significantly improved up to 25%. This is due to the fact that more diffuse light is present in morning and evening time. If we compare to the conditions on a sunny day and cloudy day, the average energy gain is higher in a cloudy day condition. It is the same actually. It is linked to the fact that more diffuse light is present in a cloudy day condition. Let's move on to the next factor, which is the albedo, or surface reflectivity. The albedo is defined as the light reflected by the ground to the total solar radiation. The albedo of, on this table below, you can see different albedo for different ground surface, from water with an albedo of 5 to 8% to fresh snow with an albedo of 80 to 95%. We have simulated the gain of bifacial modules installed in the recommended installation methods compared with monoperc modules installed at 30-degree tilt angle. For instance, if we take an example for green grasslands, the expected gain would be from 7 to 9%, with an albedo varying between 15 to 25%. IC Constant Institute have collected more than 25 project data with bifacial modules installed side by side with monofacial modules, and they have plotted the bifacial gain versus the albedo. What we can see from this trend on the right diagram is that there is actually quite a large deviations on bifacial module gain. The modeling is complex. One factor among others which influence the gain. However, some simulation software allow the simulation of bifacial module and help to get an estimation of the gain for your project. Let's go to the final part of the presentation, which is the applications. First, we will see some field data, and in the second part, some yield benefits, simulated data under various environmental and installation conditions. The first project we would like to present is a project installed in our R&D center in China. The total installed capacity was around 6 kilowatt peak. The module power and the monofacial, the modules were installed at fixed tilt with a 20-degree tilt angle. We have monitored the energy 10 months, and we have seen that bifacial module generates 7.8% more than monofacial PERC module installed in the same configuration. The second project we would like to present is a power station project installed in the module power for the bifacial module was 345, and the inverter similar to before, where was a string inverter. As you can see, the gain is varying between the lowest value 11.5%. In average, bifacial monofacial module installed in the exact same configuration. Let's now go through some simulated data. Europe have different climates, and thanks to the simulated data, it could give you a good idea of the potential gain that you would have for your future projects. So first, I want to mention that for the simulation, we will show the impact of 1 or 2 parameters on the gain, but it's important to mention, to keep in mind that the gain can always be improved by optimizing all parameters. Here, for the first case, we made varying the height, and we took for the climate Spain, where the climate characteristic has high irradiance, high temperature, and a lot of direct sunlight. we simulated a 5 megawatt peak ground mount installation. So first, we simulated the annual yield of the baseline reference project, which is a mono-PERC 300 watts modules installed at 28-degree tilt angle. If we install bifacial module in this configuration with a height at 0.5 meter, a tilt angle 28 degree, and an albedo which can be considered as 40% since it is a sandy region, the gain by installing bifacial module would be 7%. Now, if we install bifacial module, but we change the height from 0.5 meter to 1.5 meter, the gain would be 9%. The second configuration we study is a project in UK or Ireland. It's a 200 kilowatt peak commercial installation installed on a flat roof. Here, the baseline mono-PERC product 300 watts was installed at 15-degree tilt angle because it's usually the case for flat roof system. If we install the bifacial module with a height of 0.3 meter, tilt angle of 15 degree, and albedo of 25%, which correspond to concrete ground albedo, here the gain would be 2%. But if we change the tilt angle from 15 degree to 30 degree, we see that the gain is significantly improved. The gain would be then, by using bifacial module, would be 7%. Let's study some cases in the north part in Scandinavian countries, where the climate characteristic is long winters and in part of the year little sunshine, but in winters we have snow. Here, a 2 megawatt ground mount installation has been studied. The baseline mono-PERC installation installed at 30-degree tilt angle give the following result you can see on the top part. If now we would install bifacial module with at a 1 meter height, a tilt angle of 30 degrees in summer months. So in summer months, let's say there is no snow, so the surface underneath is grass. The albedo would be 20%. In this case, we would have a very limited gain. Now, if we consider the bifacial module installed in the same configuration, but in winter months, let's say underneath the module, there is some snow, fresh snow. Then the albedo would be significantly increased up to 80%. In this case, we would have a gain by installing bifacial module of 11%. The fourth case is a Central Europe installation, 100 kilowatts on flat roof with white gravels underneath. Here, the baseline simulation is using mono-PERC products with a 10-degree tilt angle. And if we install bifacial modules, if we change the tilt angle to 20 degree and the albedo of white gravel is simulated at 35%, in this case, the gain compared to the baseline simulation would be 10%. If we go a little bit out of Europe now, in Egypt, where the climate is hot and we have also high irradiance, and we simulated a 50 megawatt peak ground mount installation. Here we change the simulation. The baseline simulation is a polycrystalline modules, 330 watt peak installed at 30-degree tilt angle. By installing bifacial modules at a height of 1.5 meter, a tilt angle of 30 degree, and the albedo estimated at 40%, it's a sandy region, then the gain of installing bifacial module would be 10%. And finally, our last case is an installation in USA, a 300 kilowatt peak commercial roof installation where we placed a highly reflective roof coating. The baseline simulation is a monoperk module installed at 15-degree tilt angle, and we consider that bifacial modules are installed at a height of 0.2 meter, but here the albedo is quite high because highly reflective roof coating has been used, so we can consider that the albedo is 80%. By using bifacial module in this configuration, we can have a gain of 7%. So in conclusion, we have seen that the installation of bifacial module in a solar power plant systematically leads to a gain in the power generation compared to installing standard modules. The bifacial module gain depends on many external factors, the mounting method, the climatic condition, the albedo, etc. And we have seen from the simulation that by optimizing the different parameters, the gain can be significantly improved. Field data shows that there is an actual extra yield. Simulation have shown also a gain in different environmental and installation conditions. Finally, JA believes that bifacial modules is a promising technology since it shows clear benefits to decrease the levelized cost of electricity. Thank you very much for your attention. If you have any interest, if you have any more questions about JA Solar bifacial module, please do not hesitate to send us an email at bifacial@jasolar.com. Thank you.
Yes, thank you very much for that presentation, Morgane. I think now we've got a couple of questions that have been submitted from some of our attendees today. I guess if there's either you or Henning could answer these. I think one of the first ones we received was perhaps just on the operations and maintenance of bifacial modules. What kind of considerations do people have to take into account, particularly in the cleaning of these panels?
There is no specific, let's say, additional cleaning procedure for bifacial modules. So also, since bifacial module can be produced framed or frameless, then frameless module would be automatically cleaned. But framed module, we would need to see, depending on the climate, if it's in a desert area, then climates will probably need to be more regular. And if it's a standard climate, standard European climate, then it is standard cleaning procedures.
Okay, great. Then moving on to some other questions. When it comes to some of the other components that are required, particularly the inverter, when it comes to using bifacial panels, did you require any kind of special inverters or other components, or do the standard components work just as well?
We recommend to use a slightly bigger inverter. So you need to look at AC-DC ratio, which is slightly different from standard inverter, standard system. A slightly bigger inverter in order to, since bifacial module would generate more energy when conditions are optimum, you have an additional energy gain, then you will need to plan a bigger inverter.
Okay, great. We do have a few additional questions. I just wanted to bring the attention of our attendees to the poll on the screen. Just the last of 3 polls that we're conducting during today's webinar. How can bifacial module technology become fully bankable? So if you could pick one of the 5 answers there, just whether or not they are bankable for your projects. the simulation software needs to be more advanced, whether you need more deployment globally and more real data to take into account, or whether or not this comes down to the technical agencies and their need to provide more assurances. But again, just moving on to some of the questions that have been submitted so far this afternoon. What about when it comes down to the bifacial panels and some of the tracking devices that are used? How or what kind of an impact does that have on the performance of bifacial modules?
Yes, so this is an important point that we could not mention in our presentation because unfortunately bifacial module gain with tracking system cannot be estimated accurately right now. This is why we didn't present any numbers except from the field data with tracking system. So tracking system definitely can bring an additional benefit for bifacial module installation. So if we refer to the field data that we have shown for the second project for China, installed in China, we saw that installing bifacial module using tracking system leads to a gain of 10.5% compared to monofacial module installed as well with a tracking system. So for sure, it brings benefit for the system. And we believe that it is very interesting to decrease the levelized cost of electricity. It is very interesting to use bifacial module combined with tracking system.
We've had quite a few questions from attendees today on some of the simulations and the data that's been presented. I was wondering if you could just perhaps go into a bit more detail into how you've reached the simulations that you have done, or what software you've used, and just basically give some of the attendees a bit more insight into those.
Sure. So right now, what is available is so the PVSys software can give a bifacial module gain simulation. So not all the version, only the version, the newest version 6.6.7 can allow the simulation of bifacial modules. And only the version 6.7 right now allow the simulation of bifacial module and tracking system. But this simulation right now are still a little bit limited to a limited shed model, so 2D model, not 3D yet.
And another kind of popular factor in some of the questions that we've seen so far this afternoon, perhaps quite an obvious topic when it comes to bifacial modules at the moment. What are some of the price considerations? How much more expensive are bifacial modules compared to some of the industry standards poly modules on the market, and what kind of cost reductions are you seeing?
Yeah, let me step in here, please. This obviously is more an answer to or a question to be discussed. Yeah, face-to-face directly with the customers. It's a bit hard for us here in such an open plenum to really make any comments on pricing. So if people are interested, we've shown the email account bifacial@jasolar.com, or if you already have a key account manager in JA, you're obviously very welcome to contact your key account manager.
Okay, perfect. Moving on then to some other questions. Has JA Solar published any kind of design guidance for the applications of the bifacial module, or is there any kind of top tips that you can recommend for taking into account bifacial modules into your project design?
So regarding the installation method, we have detail into the presentation. We have given a recommendation in this presentation. The tilt angle, the height, The spacing between rows is very important parameters to consider for the installation of bifacial modules. For any further detailed question, we will be pleased to answer more specific question on bifacial module design installation.
And what about some of the applications on floating solar? I know that this is quite an intriguing area for the industry. What kind of room do you see for bifacial modules in some of the floating solar applications that we're seeing grow in popularity across the world?
What we can see is the installation of bifacial module can be very interesting for big projects in environment that we studied in desert area. We also see beneficial the installation of bifacial modules on water because in the morning, evening time, the reflection of water would be quite intense, and the gain of installation of bifacial module on water is quite interesting. On flat roof system, flat roof, we saw that also placing the module with a quite high, quite a big tilt, with also a little bit above the ground, if possible, if the designer allow it, would give an interesting gain.
Perfect. Thank you, Morgan. Perhaps I've got time for one or two more questions then. There's one particular question here. When it comes to the performance of some of these bifacial modules, would any breakage on the rear side of the panel, would that affect the entire panel's performance, or just the back side of it?
I'm not sure what you mean by breakage. Do you mean if there is any kind of shading on the module rear side, or?
Yeah, so if there's any kind of shading or defect on the rear side of the panel.
Yes, so we have also studied this in our R&D center. We saw that, in fact, shading on the module rear side will not affect the overall performance of the module, because the module rear side generation is only a part of the bifacial module generation, and placing the let's say the rack of the system at a distance of at least 50 centimeter from the module rear side will the shading will be limited, and it will not affect the performance of bifacial module, and of course it will not affect the front side power generation of the module. Okay,
perfect. Thank you very much once again, Morgan. If I could just then conclude with a look at the results of the poll. So obviously we asked there whether or not or how can bifacial module technology become fully bankable. The overwhelmingly favorite answer there is that more deployment is needed globally rather, and more real-time data is needed just to fully take bifacial technology into the realms of bankability. The 28% of you said that the simulation software needs to be more advanced, which is perhaps something that some of the software designers can look at. And the other three answers there, as you can see on your screen, not quite as popular as those two. But unfortunately, that is all we have time for this afternoon. A quick reminder that today's presentation and slides will be emailed to all who have registered for today's webinar. It will also be published shortly on the PV Tech portal. But other than that, many thanks to Henning and Morgan for today's presentation and insight, and JA Solar in general. And again, thank you very much for attending today's webinar. I hope you will have a great afternoon.
Thank you very much, Joel.
Thank you.